Here we have the graph of the straight line f of x equals 4x and the curve g of x equals x cubed. We will be interested in the area between these two graphs. But before we do that, let's look at how to draw these two graphs. Let's start with f of x equals x cubed. Now, this is an example of an odd function. What does that mean? Let's look at f of minus 2. Well, that's minus 2 cubed, which is minus 8. But minus 8 is the same as minus f of 2. In general, for an odd function, f of minus x is equal to minus f of x. So in this example, if we know what f of minus 2 is, then f of 2 must be plus 8. So f of 2 is somewhere up here. And you see we can get this value by reflecting this value through the origin. So once we know, say, the part of the graph for positive x, we can just reflect all these points through the origin. So if we reflect each point through the origin, we can build up the points of the graph for negative x. Anyway, that's just an aside on how to draw the graph, so that's only just a very rough idea. So we expect the part of the graph for negative x to be the image of the part of the graph for positive x under central symmetry in the origin. That's the case for any odd function. For any function which obeys this rule here for all x. Now the graph of the line is straightforward. We only need to pick 2 points. If x is 0, for example, you can see that y is 0, so 0, 0 is on the line. Also, the coefficient of x tells us that this line has a slope of 4. So if we pick any point on this line and increase x by 1, we need to go up 4 units to reach the line. So for example, if we start at 0 and go out, say, 2 units, then we need to go up 4 times 2 is 8 units to get a point on the line. So we are going to get this area enclosed between the line and the curve. Now by symmetry we only need to look at this part, because actually this area here is the same. You know, this f of x is an odd function, so the shape of the function for positive x is the same as the shape of the function for negative x. And the line is also an odd function. The shape of the line for positive x is the same as the shape of the line for negative x. We can reflect points on the line through the origin, and we obviously get the points down here. So we only need to concern ourselves with this part, and then we just double it to get the total area. So we start by getting the area under the line from x equals 0 to x equals 2. That area is the integral from 0 to 2, 4x dx. 4x is the equation of the line. And you see 4x is entirely positive for all values of x running from 0 to 2. So we are going to get a positive answer for this integral. Okay, 4x is positive over that entire interval. So this is straightforward. We add 1 onto the power to get 2, divide by the new power. So we get 4 halves x squared, which is 2x squared. And the limits are from 0 to 2. So we plug the upper limit in for x, so we have 2 times 2 squared. Then we have a minus sign. And we write this out replacing x with 0. So we have 2 times 2 squared, 2 times 4 is 8. Because our function is a straight line, we could actually get the area without doing any integration, because the area is in the shape of a right angled triangle. The base is 2. What's the height? Well, the height is the value of the function at 2. So this is f of 2. F of 2 is 4 times 2, which is 8. So the area of the triangle is a half the base, which is 2, by the perpendicular height, which is 8, and that would give us 8. By the way, I forgot to mention this point here. Okay, how do we know that 2 is the upper limit for the integration? Well, the coordinates of this point are actually 2, 8. So that is something I forgot to do. Let's see how to get the coordinates of the point. Well, you can see both functions have the same y value at this point here. So, you know, we could call this, we could, at this point, for this value of x that we're trying to find, f of x is equal to g of x. Okay, so we need to determine what x is. Well, we know it's 2. I've just jumped the gun here by saying it's 2. But we solve this equation. Okay, so f of x is 4x. G of x is x cubed. We can write this equation like this here. Let's factorize it. We can take x out of it, so we have x into x squared minus 4. Now we have a 0 product here. These multiply to give 0. The only way that can happen is if one of them is 0. So one solution is x equals 0 from putting x equal to 0, and the other solution is got by putting x squared minus 4 equal to 0. And there's two solutions to that. X equals plus 2 or x equals minus 2. Okay, we take the positive and negative square root of 4. So that's how we found this point here. So x equals plus 2 is the x value of one point of intersection of the two functions. X equals minus 2 is actually the other one. Well, by symmetry we can get that. We could just reflect this point through the origin, since f of x and g of x are odd functions. And also at x equals 0 both functions are equal. Well, that's clear from the diagram. The next thing we have to do is get the area between the curve and the x-axis from 0 to 2, and you can see that the curve is positive over the entire interval from 0 to 2. So we need to integrate the curve, integrate x cubed dx from 0 to 2. So how do we do that? Well, we add 1 onto the power to get x to the power of 4. We divide by the new power, which is 4. Well, there's just a 1 in front of it. And our limits are from 0 to 2. So we plug in the upper limit, so we get a quarter times 2 to the power of 4. Then we put down a minus sign, write this out again, replacing x with 0. 2 to the 4 is 16, so we've 16 divided by 4, which is 4. So, to get our answer, this required area, it's fairly clear that we have to take the area that's under the curve, that's the blue area, from the area that's under the line, which is the brown area. So the purple area here is 8 minus 4, which is 4. Well, actually that's just that one region, but by symmetry we could add in this region. This area is also 4.